Hello everybody, welcome back. Today we're continuing with Chapter 6, Linear Inequalities. We're going to look at linear inequalities with two variables, and we're going to look at something a little different than the previous section. Okay, so it's not a big change, but it's just going to be a little twist on what we've done. So draw the boundary line. Remember, it's dashed or dotted. Remember, we have the dashed line for greater than or less than. Okay, that's important. We remember that. Okay, and remember solid for greater than or equal to or less than or equal to. Where do we graph? We graph of the corresponding equation. So we determine the half plane containing the solution. Remember, we did that test point right on one of the boundaries. If it satisfies it, we shade on that side. If it doesn't, we shade on the other side. Very simple. If the domain and range are real numbers, so this is what we got to look at. Remember, there's restrictions here. The domain and range. We'll talk about this. First time we've seen integers. You shade the whole thing, but if it has integers, we would do what's called stipple, or we can only graph each single point. I'm going to show you what that looks like here in a minute. Okay. So the first thing we do is we do exactly what we did last time. We're going to take the equation part, what we're interested in, okay, and we're going to solve the equation. All right, you'll notice that there's no x in this inequality. There's no big deal, so we're going to take the y to the left-hand side and solve the inequality, right? So it's very important we be careful there, okay? So you should be getting in your head that this means, okay, we're going to have a vertical line here, right? Possibility of just a vertical line because we only have the variable y. So I'm going to take my equation and I'm going to start rearranging for y, putting y on the left hand side. So I'm going to subtract y from both sides, right? So subtract y from both sides. That eliminates the y on the right hand side of the equation. That's why we did it. At the same time, we might as well be doing these efficiently, so we're going to subtract 6 from both sides because we want to get the constant on the right hand side, and that gets rid of the 6 on the left hand side. That's why we did it. Alright, so now we're going to take that and combine any like terms. So now we have minus 4y. Okay, we have minus 4y, and then minus 6 subtract 6 more would be negative 12. And then we divide both sides by negative 4. Divide both sides by negative 4. Right? This is really important. When we divide both sides by negative 4, the negative 4s are going to divide, leaving us with y. That's why we did it. Okay? But remember, a little trick here. If we divide or multiply by a negative coefficient, negative number, the inequality must indeed change sign. So that's important. That now it becomes less than or equal to positive 3. Right? And that's because the sign is going to change here, right? Because if you divide by a negative, this number, negative divided by negative is positive. That's why we have to switch the inequality. So the inequality is y is less than or equal to 3 or plus 3. Okay? So we're going to graph this line. This is exactly what we're going to do here. And we know that's going to be a horizontal line. I think I might have said vertical before, but I'm sorry, I meant a horizontal line. If I did say that, I do apologize. So it's a horizontal line going through with all y values of 3, right? And it's going to be less than that. All right? So since the y is less than 3, the solution set is below the line, right? We're going to go below because it's less than y, right? So it's less than or equal to it. Okay? Now, we got to look at the integers. So if you see up here, it says x is integers, y is integers. So that means you can't have a decimal. So that means you can't have a solid line. So you have to what's called stipple. All right? Which means you're going to plot each individual point, which I know that sounds like a headache. It actually is, so I'm going to do that here on your graph. I'm going to do it on Desmos. So when I entered this in a Desmos, we have put our integers in. So remember, it was all the y integers less than or equal to 3, so we started dots all along here. Now remember, this is going to go forever to the left and right and down, okay, but I just drew the graph that I have here, okay. So in class I'll show you, you can just put arrows down to the right or left if you want, just showing that it goes on forever. I know this can get tedious, but that would technically be the perfect graph of what it would look like, remember? So it's less than or equal to 3, so the solution is below the line, right? So it's less than, or it should say, or equal to 3. That's important, we add that in there. Okay? So it's integers, so it's discrete data, which is important. We got to make note of that as well. So by discrete data, that means that we have to make sure that we have integer values only. Right? So only, so dots. The dots will be your answer, right? So dots for your answers. Okay? You can't have any lines, you can't have any shading of the whole area. Again, I know this is tedious, but that's where you're showing all the dots. Alright? Let's take a look at example 2. Remember, we're worried about the inequality. It's integer value, so you're going to have the same idea in this next graph. So let's graph our equation. It's already in y equals mx plus b form. So what we'll do is we'll graph that line and we'll see what it looks like in Desmos, okay? So you notice in example 3, I'll go to the point 0 and 1. That's the y-intercept. I'll open the dot because it's not included. There's no equal sign on there, so it's not included. I'll go down 5, 1, 2, 3, 4, 5, right 2, 1, 2. Open it again because it can't go through. I'll draw my line. Remember, this line doesn't really exist here. This just helps me show where I can put my integer points. So the black line is really not. It's just kind of there as to show me where I can put my line at, right? Now remember, it's all the y values less, so it's going to be left and down. So then we put in all of our points. I know it's tedious, but there are all the integer values for the graph. All right, everybody, we're going to do example 3 here for 6.2. Now, it says a sports store has a net revenue of $100 on every pair of downhill skis and $120 on every snowboard sold. The manager's goal is to get a net revenue of more than $600 a day from the sales of both items. What combination of ski and snowboard sales will meet or exceed? So that means meet would equal, exceed would be greater than. So it's greater than or equal to. So let's write down what we know and what we have. Let's first, you may remember from last year, we have to set our variables equal to, right? So we'll let x equal the pairs of skis, the number of pairs of skis, and we'll let y equal, the number of awards. Okay. So we set up our, we did this in grade 10 last year. This is creating a linear relation or linear equation. Now we're just going to do a linear inequality, meet or exceed, right? So our equation is going to look like 100x plus 120y, and that has to be greater than or equal to 600 revenue, right? Because it's the cost of each pair of skis multiplied by the number of skis sold, plus $120 for each snowboard, multiplied by the number of snowboards sold, greater than or equal to 600. So there's your inequality. And that's what we're going to graph. The easiest way to graph this, in my opinion, would be to do the x and y intercepts. So first what we're going to do is we'll find the y-intercept. All right, and it doesn't matter the order here. You do this, y-intercept. All right, and to find the y-intercept, we let x equal 0, right? Find the y-intercept, we let x equal 0. So we grab our equation. All right. Everywhere we see 0, or sorry, everywhere we see x, we put in 0. That'll leave it 120y. And again, you don't need the inequality here. Sometimes I'll forget that. It's not a big deal. It's just you're finding x and y intercepts, so you can switch to an equation for now. And that'll allow you to get y equal to 5, right? Dividing both sides by 120. All right, y is equal to 5. So our y-intercept is going to be 0 and 5 for the y-intercept. Okay? And you do the same thing for the x-intercept. This time we'll let y equal 0. Let's do that for a minute. So we'll do the x-intercept. So find the x-intercept. Do the opposite, obviously. Let y equal 0. Right? Rewrite your equation. This time letting x or y equal 0. So y is 0 this time. So that's going to give you 100. X is equal to 600. And that allows you to get x equal to 6 divided both sides by 100. So your x-intercept is 0, or sorry, 6 and 0. Okay? And you just plot those 2 points on your graph. Now, you'll recognize that x and y, if it's the number of skis and number of snowboards, that'll tell you that, oh, sorry, oh, it's still not here. That's going to say that, that's going to tell you that x is an element of the whole numbers, and y is an element of the whole numbers, because you can't have negative. You can have 0, but you can't have negative. So those are basically the restrictions on the variable. So you only need one quadrant. Quadrant 1, where all the x and y's are going to be positive. So I'll show you what that graph looks like in a minute. So here's your graph. You plot the point 0 and 5, 6 and 0. Draw a line. Remember, this dotted line doesn't count. It just shows you where to put the points. And remember, it's all the points above and to the right, right? Because it's greater than or equal to. And there you are. And you're all set. So that's it for this video. And in the last video, we'll finish up the section with example 4. Thanks everybody for watching, and I hope it helps.